Today we're going to solve LeetCode number 167, 2sum2, input array is sorted. So given a 1 indexed array of integers, instead of 0 index, 1 index, an array of integers numbers that is already sorted in non-decreasing order, find two numbers such that they'd add up to a specific target number. Let these two numbers be numbers index 1 and numbers index 2, where angles 1 and 2 are between the ranges of 1 and the length of the numbers inclusive. This is 1 index. Return the indices of the two numbers index 1 and index 2 added by 1 as an integer array index 1, index 2 of length 2. The test generates such that there's exactly one solution. You may not use the same element twice. Your solution must only use constant extra space. Okay. So, first thought here is if we have an array, let's say 2, 3, 4, and the target is 6. We go through each element one by one. So this is the focus element right now, and then we go through the rest of the array and check if adding those two elements equals to target 6. 2 plus 3, does that equal 6? No. 2 plus 4, does that equal 6? Yes. So we return the indexes 1 and 3. Let's have a better example. So let's say we have the array 1, 2, 3, 7, and 11. And our target is 18. So if we use that naive or brute force approach, we go look at number 1 as our target first, and then scan through the rest of the array. 1 plus 2 equals 18, no. 1 plus 2 equals 18, no, etc. You see that none of them added by 1 equals 18. So our next target element is 2. And again, we scan through the array. 2 plus 3 equals 18, no. 2 plus 7 equals 18, no. And then finally, once we reach 7 here, we see does 7 plus 11 equals 18? Yes. So you return the one index position of those. But this is O of n squared time, because we do have a nested loop where we iterate through the array. We iterate through the array in a nested loop. A better way is if we look at a previous two-sum approach, is to store the elements we've seen in the dictionary. Like here, we store, let me just erase these. We store the elements we've seen in the dictionary. So 1, and we check does the difference between the target and the focus number exist in the dictionary. And does 18 minus 1 exist? Have we seen that number? No. So we move on, and etc. So same with 2, same with 3, same with 7, and then 11. We check. Once we reach 11, before we add it here, we check does 18 minus 11 exist in the dictionary? It does. So we return the index. And in the dictionary, we would have the key would be the value, and the key would be the element in the array. So like here, the key would be 1, and the value would be the position, one index position. So it would be like 1 in this case. And for this guy 7, the key would be 7, and the index or val would be 1, 2, 3, 4. But the question specifically states your solution must only use constant extra space, and with the dictionary we use extra space of O of n. So where n is the length of the array, so that won't quite work. what else can we do? Well, we can take advantage of the fact that this is sorted. So if we look here, we see that, let's change our target to 14 here. Now obviously what equals to 14, 3, and 11. So if we have our target 3, and we look at 7, we always see C, that's 3 plus 7 is 10, which is less than our target. So obviously, we have to find a bigger number where the sum equals to 14. So instead of 7, we look at 11, which is obviously bigger than 7, and we see 3 plus 11 is 14. Okay? And we can use this idea for the entire array. So if we have target 14 here, we can start here and here. So what's 11 plus 1? 12. And 12 obviously means that's less than 14. Okay, so the participants in the sum, one has to be bigger. Ideally, it should be bigger by 2. But anyway, it has to be bigger. Should we move this pointer to the left here? No, because 7 is less than 11. Because this is sorted in non-decreasing order, so if you move this pointer here, we're guaranteed to have a lesser value. So what we should do is move this pointer here. Because then we get 2 plus 11, and we're guaranteed something that's bigger than 12. So what's 2 plus 11? 13. 13 still less than 14, so we move this guy here. 3 plus 11, that's 14, we have our answer. Similarly, I looked at when the sum is less than the target. If the sum is greater than the target, like if we have 15 greater than 14, like if somehow we have 15 here and our end pointer is here, 15 plus 3, 18, so that's bigger than 14, so one of the participating values in the sum has to be smaller, so we move this guy here because then we're guaranteed a smaller element. Okay, and that's how we're going to do the two-pointer approach. It's linear time, and the space is only constant extra space. Okay, so what we want to do here is initialize our start pointer to be at the beginning of numbers position, and end pointer to be equal to the last position in numbers, so when numbers minus 1, and while start is less than end here, because it can't be start. Even though we're guaranteed exactly one solution, I still like to have this condition here instead, this while condition, so we keep looping through. And we don't do start less than equals end, because if start and end are at the same position, that's not good, because we can't use the same element twice. So while start less than equal to end, and this is also good just in case there's actually no solution that exists. While start is less than to equal to end, we have sum current sum equal to nums at position start plus nums at position end, and if current sum is equal to target, then we return the one index to value positions that the numbers are at in an integer array. Return start plus 1 and end plus 1. Okay. Else if we don't meet this condition, if current sum is less than target, what we want to do is move the start pointer to the right to make the number bigger. Start plus equals 1. Else, and minus equals 1. Else, if current sum is greater than target, then we want one of the participating numbers in the sum here to be smaller, so we decrement end to get to a smaller value since this array is sorted. Okay, and we're guaranteed answer anyway, so I'll try running this. Numbers. Okay. Okay, and I'll try submitting. Perfect. Thanks for watching.